problems. Today we will start problems on electric charges and field. Very simple, easy to understand. Sir, how many look at the question. How many electrons are to be removed from a body in order to charge it up to 25 microcoulomb? Is the question. See, there is an object which is to be charged positively. A removal of electrons. Removal means what? Removing the electron results in positive charging. What is the magnitude of the charge we want? Charge required is equal to charge required as 25 microcoulomb. How many electrons are to be removed? We must calculate. What is the charge on each electron? It is a known constant. 1.6 into 10 power minus 19 coulomb. Okay. So 25 microcoulomb charge is required. Number of electrons we don't know. E is equal to charge of the electron is known. 1.6 into 10 to the power of minus 19. Now, let me use this relation. According to quantization rule, Q is equal to plus or minus Ne. Q is equal to plus or minus Ne. But here, since the charge considered as positive, I retain only plus sign and neglect that minus sign. So, in place of Q, I must write 25 micro stands for 10 power minus 6. Remember, micro stands for 10 power minus 6. Should be equal to N into E is 1.6 into 10 power minus 19. So, in that case, what is the value of N? N is equal to 25 into 10 power minus 6 whole divided by 1.6 into 10 power minus 19. So, N is equal to 25 into 10 power minus 6 divided by 1.6 into 10 power minus 19. Now, let us calculate it. You must do this calculation. Using a calculator, you simplify this and put the answer in the WhatsApp group. Let me see that. Okay. N is equal to 25 into 10 power minus 6 divided by 1.6 into 10 power minus 19. Understood clearly? Okay, you must solve this problem. Problem number 1, answer you must put in the group. Right. Question. Simple question. How do you charge a body positively up to 1 coulomb? Simple question. How do you charge a body positively up to 1 coulomb? This is for your work. This is for your work. One problem we have solved here. Of the same kind, I am giving you the second problem. You must solve this. You must solve this as homework and put the answer in the WhatsApp group. How do you charge a body positively up to 1 coulomb? Okay. Read this question, understand this question, and based on the previous concept, you must solve this problem. Okay. Third question. Can we charge a body positively up to 3.8 into 10 power minus 19 coulomb? That's the question. See the question. Can we charge a body positively up to 3.8 into 10 to the power of minus 19 coulomb? That's the question. We have to check whether it is possible or not. So what do we do now? Very simple. Charge they have given. Let me write down it. So answer, adರಲ್ಲಿ charge they have given 3.8 into 10 power minus 19 coulomb. And E is very well known to us, 1.6 into 10 power minus 19 coulomb. Now let me just try to find out the N value. So Q is equal to Ne, positive charge, I am considering only positive sign. So this is 3.8 into 10 power minus 19 equal to, N is not known, E is 1.6 into 10 to the power of minus 19. So this 10 to the power of minus 19 cancels with 10 to the power of minus 19. You are left with N equal to 3.8 by 1.6. But 3.8 by 1.6 is a number which is a fraction, or 2 point something you get. 2 point something. But what do we know? N must be a counting number. N must be a counting number. ಆದರೆ ಇಲ್ಲಿ 2.3 2.5 ಈ ತರ ಎಲ್ಲ ಬಂದ್ರೆ ಆ ತರ electrons ಇರಲ್ಲ. Electrons added or removed must be integral multiple of the electronic charge, the total charge must be. Therefore, the number of electrons that you add or remove should be a natural number. Counting it ಸಿಗಬೇಕು ಅದು 2.5 ಅಂತ ಬಂದ್ಬಿಡ್ತು ಅಂತ ಇಟ್ಕೋ ಈಗ. 2.5 electrons cannot be added or removed. Therefore, such a charge cannot be there. Therefore, this is not possible. You cannot charge a body up to 3.8 into 10 to the power of minus 19 coulomb. ಅರ್ಥ ಆಯ್ತಾ ಇದು ಸರಿಯಾಗಿ? 3.8 into 10 to the power of minus 19 coulomb is not a possible charge because the number of electrons involved in that becomes fractional electronic charge. Fractional electronic charge does not exist freely. Therefore, this is not possible. Understood clearly? It is not possible. 15.4 into 10 to the power of minus 16 coulomb. Whether it is possible or not, you must check. Write down. You must do this as homework. Fourth problem, homework. Can we charge a body positively up to 14.4 into 10 to the power of minus 16 coulomb? Is the question to be solved. You check it in the same sense. ನಾನು ಒಂದು ಪ್ರಾಬ್ಲಮ್ ಮಾಡಿ ತೋರಿಸಿದ್ದೀನಲ್ಲ, apply the same rule and try to solve this. Okay? We'll move on to the next. 2-point charges. Two-point charges of 2 microcoulomb and minus 5 microcoulomb are 25 centimeters apart in free space. Find the nature and magnitude of the force between the two charges. This is the question. Very simple question, direct question, easy to answer. We know that if you have two charges separated by a certain distance, we know that the force in between is given by 1 by 4 pi epsilon naught q1 q2 by d square. Remember, 1 is a constant, 4 pi constant, epsilon naught constant. This whole term is a constant. If you put the epsilon naught value and pi value here, this ratio 9 into 10 to the power of 9 q1 q2 divided by d square. Understandable? So, yaudidu 9 into 10 power 9? These two constants I have replaced it by 9 into 10 to the power of 9. If you put the value of pi and epsilon naught andre ಎಷ್ಟು ಅಲ್ಲಿ, where epsilon naught is 8.854 10 power minus 12 SI units. Okay, if you put that value there and do the calculation of this, you will end up with a number nearly equal to 9 into 10 to the power of 9 Newton. 9 SI units. Newton bada SI units itkonಡ್ರೆ. Later we can think of writing the unit for that if necessary. So this is 9 into 10 to the power of 9. Which are the two charges? 2 microcoulomb and minus 5 microcoulomb. But keep this in mind. I will substitute only the magnitude of the charges. 2 micro, 10 power minus 6. Minus 5 micro, don't consider the minus sign. Minus sign is just to judge the nature of the force. ಹಾಗಾಗಿ minus 5 ನ ಬರ್ಕೊಳ್ಳಲ್ಲ, ಬದಲಾಗಿ I just write 5 into 10 power minus 6. Carefully observe, here in the charge that they have given, they have minus sign. I am not using that here. This whole thing divided by the distance square. How much is the distance? 25 centimeters. But this is in centimeter. We have to convert that and put it in meters. How do I do that? 25 into 10 to the power of minus 2. So 25 centimeter na 10 power minus 2 ಇಂದ multiply ಮಾಡಿದ್ರೆ it gets converted into meters. Now you must simplify this part. 9 into 2 into 5 divided by 25 multiplied by 10 to the power of 9 minus 6 minus 6 plus 2. Understandable? So this is 5 ones are 5 5s are 9 2s are 18 by 5. It is, I am writing it here, 18 by 5. F is equal to 18 by 5 into 10 to the power of, see, 9 plus 2 11. 11 minus 12 is minus 1. 10 power minus 1, or it is 3. 5 3s are 15. Ille 3 30.6. Correct? 3.6 into 10 to the power of minus 1. When that comes to denominator, it becomes by 10. 0.36 Newton is the magnitude of the force. Since the two charges are of opposite sign, opposite polarities, they attract each other. So this is the force magnitude, and nature of the forces, nature is attractive. You understand this? The force is attractive. Okay? Copy down this problem. ಇದೇ ತರದ ಒಂದು ಪ್ರಾಬ್ಲಮ್ ನಿಮಗೆ ಕೊಡ್ತೀನಿ. You must be able to do that. 2 point charges of magnitudes 10 microcoulomb and 3 microcoulomb minus 10 microcoulomb and 3 microcoulomb, let it be, attract each other each other with a force of say 0.8 Newton. Okay, Newton in a medium of dielectric constant 3. Here K stands for dielectric constant, or sometimes K is also written as epsilon r. Both of them, they mean the same. In some books they refer to it as K. In some other books they may represent it as epsilon r. Relative permittivity, it is a number without unit, is equal to 3. Find the distance between the two charges. Now the question is something like this. There are 2 point charges. Okay, magnitudes are 10 microcoulomb, minus 10 microcoulomb and 3 microcoulomb. Let me write the answer here. So charge 1 considered as minus 10 microcoulomb. Charge 2 considered as 3 microcoulomb. The force in between is 0.8 Newton. Distance of separation not known, and epsilon r is equal to 3. Now how do I write the formula? See, this is not in air or vacuum. It is expression as 1 by 4 pi epsilon naught epsilon r. It should be multiplied by that number. Epsilon naught epsilon r. It is only for vacuum. But now you have a medium. Therefore, it should be multiplied by the denominator must be multiplied by epsilon r. Q1 Q2 divided by distance square. I think you can follow it. So F is equal to 1 by 4 pi epsilon naught. This whole thing is a constant. Alva? Adan matra I will write it as 9 into 10 to the power of 9. By epsilon r is 3. Q1, Q2, they have given the two charges. We will substitute the respective values. Did you understand this part? Please check this. 1 by 4 pi epsilon naught is 9 into 10 to the power of 9. Epsilon r is 3, which they have given. I have written it as it is. So F is how much? 0.8 Newton is 9 into 10 to the power of 9 divided by 3 into charge 1. Minus 10 is there, but minus sign is only for judging the nature. You consider now only the magnitude. 10 microcoulomb into Q2. In place of Q2 it is 3 microcoulomb. Therefore 3 into 10 to the power of minus 6 divided by the in between distance is not known. We have to find out that. This is d square unknown. Now let me solve for d square. D square is equal to, see here, this 3 can be cancelled with the 3. 9 into 10 is 90 into 10 to the power of 9 minus 6 minus 6. 9 minus 6 minus 6 is 9 minus 12 minus 3 it becomes. Okay, minus 3. And in the denominator we get this 0.8. Correct? 9 into 10 90. 3 cancel agide. 10 power minus 3 ulidide by 0.8. But in a square term, for finding d, I need to take the square root. Square root tagoluvaga, we should not have this odd power. Power must be made even. How do I do that? Very simple. See, 900 divided by 8, I will write this as. 0.8 can be written as 8 by 10. 10 jumps to numerator. 10 power minus 3. In the next step, I write it like this. 90 divided by 8, 1 0 multiplied to that, 10 power minus 2 it becomes. Now you can take the square root very easily. D is equal to 9 by 8. 90 by 8 within square root into square root of 10 power minus 2 is 10 power minus 1, or it is root of 90 divided by 8 whole divided by 10 power minus 1 becomes 1 by 10 by 2. Simplify this, you get the required result. Okay, ಅದನ್ನು simplify ಮಾಡಿ ಬರೀತೀರಾ? ಮಾಡಿ ಬರೀರಿ, you get the required result. Observe the problem carefully, correct ಆಗಿ ನೋಡ್ಕೊಳ್ಳಿ ಒಂದ್ಸತಿ. Two-point charges they have given of magnitudes minus 10 microcoulomb and 3 microcoulomb. They attract each other with a force. Force is also given 0.8 Newton. In a medium of relative permittivity 3, they say. Find the distance between the two charges is the question. So two charges, their magnitudes have been given, force is given in between, distance is to be calculated, relative permittivity is known. So we first write down the expression for force. Force is 1 by 4 pi epsilon naught epsilon r q1 q2 by d square. See here carefully. We are multiplying epsilon naught with epsilon r because it is in some other medium, not in free space. That's why q1 q2 by d square. Anyway, 1 by 4 pi epsilon naught is 9 into 10 power 9. But epsilon r separately it is written here to q1 q2 by d square. Now let me put the values. F is 0.8. This is 9 into 10 power 9 by 3. This q1 is 10 microcoulomb. But I didn't put that minus sign. You must understand why. Because here by calculating the force I must consider only the magnitude. So then what is this minus sign meant for? If you ask a question like that, I would say this minus sign is meant for judging the direction. Okay. So 10 into 10 power minus 6, 3 into 10 power minus 6 by d square. Now on solving for d square you get 90 into 10 power minus 3 by 0.8. But d square is there. To get the value of d, I need to take the square root. While taking the square root, we should not have odd power. Power reduce ಮಾಡಕ್ಕೆ ಏನು ಮಾಡಿದೆ? 0.8 can be written as 8 by 10. 10 jumps to numerator. 900 it becomes. Okay. 900 by 8 into 10 power minus 3. 10 power 1 will be multiplied with this. So it becomes 90 by 8. 10 power 1, 10 power minus 3 is 10 power minus 2. Understood or not? Now take the square root for this. You will get the required result. You must do that solution. Okay? ನೋಡ್ಕೊಳ್ಳಿ ಒಂದ್ಸತಿ. Okay. 7th problem I'm considering. Hundred electrons have been added to a metal sphere. 100 electrons have been added to a metal sphere. And it is placed at a distance of 3 centimeters from another metal sphere which has lost 200 electrons. find the nature and magnitude of the force in between them. Very simple. See, 100 electrons have been added to a metal sphere and it is placed at a distance of 3 cm from another metal sphere which has lost 200 electrons. Find the nature and magnitude of the force between them. See here, first metal sphere has been added with 100 electrons. When you add electrons to a body, what happens, you tell me? When you add electrons, tell me what happens. When you add electrons, the body will gain negative charge. Adrinda, idu negative Q. And there is another body from which they have removed the electrons. When you remove the electron, it will gain positive charge. These two have been separated by a distance of 3 centimeters. Okay. Now first calculate the negative charge magnitude and positive charge magnitude. So charge on 1, I call this as sphere 1 and this as sphere 2. Charge on 1 is negative charge due to 100 electrons. So charge is equal to Ne alpha formula. Negative adre minus Ne, positive adre plus Ne. So minus N is how much here? 100. E is 1.6 into 10 power minus 19. This becomes 116. One decimal shift adre. Innone shift adre 160 into 10 power minus 19 coulomb is first charge. What is second charge? Similarly, Q2 is also equal to Ne but positive. Here we had N1 number of electrons, here it is different. N2, 200 anta kottidare. You have removed it, therefore positive sign. So it is plus 200 into 1.6 into 10 power minus 19, which can be written as what? 320 into 10 power minus 19 coulomb. Okay, these are the two charges. Now we need to find the nature and magnitude of the force. What is the formula for force? Force is 1 by 4 pi epsilon naught Q1 Q2 by d square. See, in the present problem, they have not told anything about the medium between the two charges. Yavadadru medium idya ilva anta enu helilla. Since they have not specified any medium, you can assume that it is air or vacuum. If you assume that it is air or vacuum, then formula will be written like this. So 1 by 4 pi epsilon naught is a known constant into what is Q1? Don't consider sign, only magnitude. 160 into 10 to the power of minus 19 into 320 into 10 to the power of minus 19 whole divided by the distance in between. 3 centimeter it is therein. So centimeter to be expressed in meters. 3 into 10 to the power of minus 2 whole square. Now let me simplify this further. 9 into 160 into 320 divided by 9 into 10 to the power of, see here, 9 is present here, minus 19. Minus 19 again for this. This is minus 2 square, minus 4 when comes to numerator, becomes plus 4. All of you please simplify this. It is 160 into 320 multiplied by that power. Okay. You must solve this and write the answer. Okay. I'll explain it once again. Carefully observe. Simple. See, 100 electrons have been added to a metal sphere. First point. One metal sphere, 100 electrons have been added. When you add electrons, body gains the negative charge. How do you calculate it? Q is equal to Ne. N is how much? 100 electrons. E is 1.6 in 10 power minus 19. On simplifying this, I got the charge magnitude as minus 116 to 10 power minus 19. Now, if you consider the second sphere, for the second metal sphere, they have removed 200 electrons. When you remove, lost and it has lost, andre 200 electrons have been removed out of it. Remove madadaga positive charge barutte. So Q2 is equal to N2E. N2 is 200, E is known, therefore it is 320 into 10 to the power of minus 19 coulomb. Now I got the values of Q1 and Q2. Now come to the force. Force formula I know. In the present problem, since they have not mentioned any medium, you can assume that it is either air or vacuum. There the force is given by 1 by 4 pi epsilon naught Q1 Q2 by d square. So if you put the values, 1 by 4 pi epsilon naught is, this whole term is 9 into 10 to the power of 9. Q1 is 116 10 power minus 19. Q2 is 320 10 to the power minus 19 divided by distance square. On further simplifying this, you end up with the required result. Understood clearly? Right. Okay. Now we'll move on. Okay. Two-point charges 5 microcoulomb and minus 3 microcoulomb are 9 centimeters apart in vacuum. Find the nature and magnitude of force between them. Also find the change in the nature and magnitude of the when minus 2 microcoulomb charges added to both. Look at the question. There are 2-point charges, 5 microcoulomb and minus 3 microcoulomb. They are 9 centimeter apart in vacuum. We have to find out the nature and magnitude of the force between them. That is the first part of the question. Okay. First let us solve that first part. In the first part, we have to find out the force between two charges, which is given by 1 by 4 pi epsilon naught Q1 Q2 by d square. Again, in this problem also, they have not specified the medium. Therefore, I can assume that it is air or vacuum. So this is 9 into 10 to the power of 9 for air or vacuum. Q1 is 5 micro. I should not consider the minus sign. 10 to the power of minus 6 divided by the distance in between is 9 centimeter, which will be 9 square, 81. Centimeter square is 10 power minus 2 square, which is 10 power minus 4. I think by now you can follow that easily. Okay? Right? Let us simplify this. 9 9s are 81. 3 1s are 3 3s. Okay? This is 5 by 3 into 10 power. 13 minus 12 is 10. Correct? 9 power minus 4 ಮೇಲೆ ಬಂದ್ರೆ 9 plus 4 13 minus 6 minus 6 12 13 minus 12 is 10, so it is simply 10 power 1 or simply 10. So 50 by 3 Newton is the force. 50 by 3 Newton. What is the nature of the force? One is positive, other is negative. Attractive. So first part of the problem is over. Now come to the second part. Added, see, this was 5 microcoulomb charge and this was minus 3 microcoulomb charge, 9 centimeters apart. Now for this they are adding minus 2 microcoulomb and for this also they are adding minus 2 microcoulomb. See here, also find the change in the nature and magnitude of the force when minus 2 microcoulomb charge is added to both. When you add minus microcoulomb and this becomes minus 5 microcoulomb. I think you are understanding. Now how do I find the force? I call this as F dash, new force. 1 by 4 pi epsilon naught Q1 Q2 by distance square, or it is 9 into 10 to the power of 9. Q1 Q2 product is 3 micro. Don't consider this minus sign. 5 micro divided by the distance in between is 9 into 10 to the power of minus 4. Okay, 9 alla, I'm sorry, 9 centimeters is there. Square madre 81. 81 into 10 to the power of minus 4. On simplifying again you end up with 50 by 3 into 10. 50 by 3 Newton. Okay, in lane banto same birthday. So magnitude is same in both the cases. But now you observe, this is a negative charge. This is what type of so even after adding minus 2 coulomb to both, minus 2 microcoulomb charge to both, we didn't get any change. Neither the magnitude is different nor the nature is different. Even after the addition of this charge, the magnitude and nature of the force remains the same. There is no change. Okay, once again ಕೇಳು, ಎರಡು ಪಾಯಿಂಟ್ ಚಾರ್ಜ್ ಇದೆ, ಒಂದು 5 ಮೈಕ್ರೋಕೂಲಂಬ್ ಒಂದು minus 3 ಮೈಕ್ರೋಕೂಲಂಬ್. ಫಸ್ಟ್ 9 ಸೆಂಟಿಮೀಟರ್ ದೂರದಲ್ಲಿ ಇದ್ದಾಗ ಎಷ್ಟು ಫೋರ್ಸ್ ಇದೆ ಅಂತ ಕೇಳಿದ್ದಾರೆ. ಫಸ್ಟ್ ಐ ಹ್ಯಾವ್ ಕ್ಯಾಲ್ಕುಲೇಟೆಡ್ ದ ಫೋರ್ಸ್ 1 by 4 pi epsilon naught Q1 Q2 by d square. 1 by 4 pi epsilon naught ಅಂದ್ರೆ 9 into 10 power 9, Q1 Q2 5 into 10 power minus 6, 3 into 10 power minus 6 divided by distance square is 81 into 10 to the power of minus 4. So on simplifying this further, you end up with 50 by 3 Newton. Now if you take up the second case, in the second case what they say, they are adding minus 2 microcoulomb to both the charges. So if you add minus 2 to 5, it becomes plus 3 microcoulomb. Minus 2 to minus 3, that becomes minus 5 microcoulomb. So on putting these two values here, if you calculate the force, you again get 50 by 3. So the force neither changes in magnitude nor changes in nature. So in both the terms they are identical. Okay, I think you have followed this problem clearly. ನಾನು ಕೆಲವು ಪ್ರಾಬ್ಲಮ್ಸ್ ಹೋಮ್ವರ್ಕ್ ಕೊಟ್ಟಿದ್ದೀನಿ ನಿಮಗೆ ಇವತ್ತು. We have solved around 8 problems. Maybe 2 problems I have given you as homework. You must solve them and practice all other problems. Very important. Okay, so we'll continue in the next class.